Is a screen visible?
Yes, sir.
Is a screen visible? So
Yes, sir.
guys, in this scenario, let's suppose I need to configure access control list so that HR department should not be able to communicate with ABC corporate company. See, we have two company here, right? One is XYZ corporate and another one is ABC corporate. XYZ corporate and ABC corporate. We have two company, right? So we are combining both company together. Let's say I have purchased my main company is XYZ and I have purchased ABC also. So guys, right now in ABC, which routing protocol I am running? EIGRPS number 20. And in my company in XYZ, which protocol is running? EIGRPS number 10. So see,
I'm so sorry to interrupt you. Recording is on, please.
yeah, sorry, brother. Thanks.
Thank, thank you so much.
Okay. Fine. So in XYZ corporate, we are running different ES number. In ABC, we are running different ES number. That means, guys, actually we are running two different protocol, routing protocol. Can router 3 and router 6, can these two router form EIGRP neighborship? Yes or no? Because on this router, ES number is 10, on this number router, ES number is 20. Can these two routers can form EIGRP neighborship? Definitely no.
No, sir.
Because remember, parameters of neighborship, ES value must match. So if I need to make communication between these two company, between XYZ and ABC, what I can do, either I can replace the configuration in ABC corporate or I can replace the configuration, routing protocol configuration in XYZ corporate. How many routers are there, guys? In ABC corporate, 3 number of routers. So easily we can remove EIGRP 20 and I can configure EIGRP number 10. After that, all these devices can communicate with each other, right? But in ABC corporate, let's suppose we have 100 number of routers. Then it is going to be very complicated, right? To replace the configuration. So in real time, actually you will not replace the configuration. What you will do, either you can extend EIGRP 20 till router number 3. I can extend EIGRP ES number 20 till router number 3. Then on router number 3, I will redistribute EIGRP ES number 20 in 10 and EIGRP 10 route in EIGRP 20. Because by default, EIGRP 10 prefixes cannot enter in EIGRP ES number 20 and EIGRP 20 network cannot enter in EIGRP 10. So on this router, actually you have to perform what? Redistribution. Redistribution. Redistribution means distributing two different routing protocol with each other, right? Or you can say distributing two different types of routing. Or guys, I can extend EIGRP ES number 10 till router number 6, right? On router number 6, I can advertise these two interfaces in ES number 10. Now again, I have to perform redistribution on router number 6 because see, this time router 6 is going to maintain two database, two topology table of EIGRP. One for EIGRP ES number 20 and one for EIGRP ES number 10. So on a single router, if we have two different routing protocols, then we can perform redistribution. Then we can perform redistribution. And remember, in EIGRP, we have two types of AD value. One is 90 and other one is 90 and 170. So 170 is the AD value for external network, right? So now let's suppose in this domain we are running EIGRP ES number 10 and in this domain we are running EIGRP ES number 20. On router number 6, I am going to perform redistribution. Means I will redistribute 20 into 10 and 10 into 20. Right? So guys, router 6 is going to advertise all prefixes of XYZ corporate, means this company, into ABC company as an external route. As a external route. Means these routes belongs to different routing domain. And for the external routes, AD value is going to be what? 170. AD value will be 170. So which AD value is more preferable? Which route is more preferable, guys? Internal route or external route?
Internal.
Let's suppose,
Internal.
yeah, internal. In XYZ, we have one subnet that is 10.1.1.0/24. Let's suppose we have same subnet in ABC corporate as well. Same subnet 10.1.1.0/24. Then XYZ corporate is not going to install this external route. Right, because in this domain we will have same route with two different AD value, one with AD value 90 and one with AD value 170. 90 will be always preferred over 170. So if you are combining two companies, makes your subnets are unique. Your subnets are unique. If these two companies are working individually, then both company can use same subnet. Like here also I can use 10.1.1.0 and here also I can use 10.1.1.0. So is topology clear to all? And then guys, we have one internet connectivity at router number 3. Other I can connect internet to router number 6 also. But for now I have only one internet connection at router number 3. So all users from ABC corporate will access internet via XYZ corporate router via router number 3 via edge router of XYZ corporate. Guys, see, this router is the edge router for XYZ corporate and this router is edge router for ABC corporate. Why I am saying edge router? Because these are boundary router. So boundary routers means last router in your network will be considered as edge router. There are two types of router in routing. In routing there are two types of, actually there are three types of routing. One is transit router, and another one is edge router. Edge router, or we can say non-transit router. What do you mean by transit router? Or we can say transit point as well. Transit point means it can be a router or it can be a layer 3 device like layer 3 switch. So a router who will forward data packet between routers. A router who will forward data packet between routers will be considered as transit router. Right? And the router who will forward data to their directly connected network and to their neighbor, that router will consider as edge router. Like if I will draw one topology, R1 connected with R2 connected with R3. Here I have one subnet X. Here I have one subnet Y. So guys, if X network want to communicate with Y network, or any devices connected with router number 1 want to communicate with a device connected with router number 3, they have to communicate via router number 2, correct? So router 2 is the transit point. Router 2 is the transit router. Because router 2 is going to forward data packet between router 1 and router 3. But router 1 and router 3 are the edge router. Because see, these routers are managing their directly connected network and network received by router 2. Okay? So in the entire network, in the complete network, your router 3 and router 6 are transit router, and this router, this router, this router, this router are edge router, right? But in the XYZ corporate, router 3 is your edge router. In ABC corporate, router 6 is your edge router, right? Even these routers are also non-transit router. Got it? Now let's understand route filtering. Okay, before that, what I am expecting that now you can configure access control list to allow or deny communication. Let's suppose I want HR department should not be able to access servers. Right here we have some, let's say, HTTP server in this domain. So HR should not be able to access server, or this HR department should not be able to communicate with finance department or with voice server management department. Or let's suppose on this server we have multiple service like HTTPS, DNS. So what I want that this PC or complete HR department should not be able to access this particular service, that is HTTPS, right? But this PC can ping to this server. So what I am expecting that you guys can configure this type of scenario by yourself. And now today we will understand route filtering, like how to filter unwanted prefix. See, between XYZ corporate and ABC corporate, we have multiple departments. This is HR department, sales department, admin department, server department, finance department, management department, again sales department, and then voice department, right? So we have some voice traffics here, voice servers. Now let's suppose my requirement is sales in XYZ should be able to communicate with sales department in ABC. So what routing protocol you are running? EIGRP. That means by default you are going to advertise all prefixes from XYZ to ABC, right? Like here I have 4 subnet, but in your scenario in real time I can have 4000 subnet as well. But see the requirement, only sales department should be able to communicate. Then brother, you will not advertise entire networks in ABC corporate. You will only advertise this network 10.1.1.0/24, and this is where we are using route filtering, right? So to advertise a required prefix or to accept only needed prefix, to advertise or accept a needed prefix, we are going to use what? Distribute list, right? We are going to use route filtering. So first of all, let me discuss some theory of route filtering. After that I will start practical. Any question guys till now in access control list or in EIGRP? Because now we will not discuss any theory part of EIGRP protocol, because my main focus is on route filtering, and
Sir,
route filtering is
can
very
you
important.
explain
Yeah.
Hello?
Yes, go ahead.
Yeah, can you explain on the edge routers why you have to go to performing the edge routers and packet filtering? Any particular
Yeah.
scenario is there?
What I am doing on edge router, brother? What is your
Yeah,
question?
in edge routers.
In edge router what?
Yeah, for accessing, right, you have to internally we have to route from the internal to external, right? Any specific things are we need to configure in the route
See,
15
first
in the
of all, my requirement is what? All users in XYZ corporate should be able to communicate with each other. Means these all departments should be able to communicate with each other. For that, what protocol I am using?
EG.
EIGRP.
Yeah,
And which router is the transit router? Router 3. Router 3 is responsible for making communication possible between all branch offices. See, between these two branch offices, router 2 is my transit router, because router 2 is going to forward traffic from these two departments. But between all departments, router 3 is my transit router. And router 3 is connected with one different network as well, or network of a different company as well, right? So router 3 have all network information of XYZ company. So I can advertise the entire network from router 3 to this domain. In the same way, router 6 have all information of ABC corporate. So I can advertise all prefixes from router 6 to XYZ corporate. Edge router means boundary router, that's it, right? Like you are using internet, maybe you have one broadband router in your home, and that broadband router is connected with one switch, and then you can connect your PCs, right? Or maybe some wireless devices. Now if you want to access internet, so you are going to connect this router to internet, right? So this time your edge router is router 1. Why? Because router 1 is connecting internal network and external network. So whatever router is going to connect internal network and external network will be considered as edge router, or your boundary router will be also considered as edge router, or you can say non-transit router. So actually why we are saying it is a edge router, because it is acting like a edge router. It is behaving like a edge router. Done. Now guys, what is route filtering? So route filtering is a process of controlling the advertisement and reception of route information to and from neighbor, like R1, R2. To advertise any prefixes from R1 to R2, R1 will advertise to R2, or R1 will receive prefixes from their neighbor from R2. So to control this advertisement routes and receiving routes, we have what? Route filtering. With the help of route filtering, we can control this advertisement and received route as well as advertised route. Like there are two company, A company, B company. Guys, in A company we have 400 networks. In B company also I have 400 networks. And if I am running EIGRP protocol between company A and B, then by default EIGRP will advertise all 400 prefix to company B and all 400 prefixes to company A. Yes or no? But let's suppose out of 400 prefix you want to advertise only 10 networks or 100 networks. So how you can achieve that? With the help of route filtering. So route filtering is a process to control the advertisement and reception of route information to and from the neighbor. Got it? It is used to manage and optimize the routing table by allowing only a specific route to be advertised or accepted, ensuring efficient and secure routing. See, if a router, what is the benefit of not advertising all 400 prefixes over advertising 100 prefixes, like company A and company B? In company A and B, in both network we have 400 prefixes. And guys, here I have one router, here I have one router. Between router I am running EIGRP protocol. So if company B is going to advertise all prefixes to company A, then this router will have 800 number of route in their routing table, right? 800 route in their routing table. You know, if someone will told you to improve the performance of this router, what you can do? You can check the routing table of router. Is there any unwanted network? Like, is there any network where company A is not forwarding traffic? Then you will get to know, yes, there are 300 routes where company A is actually never forwarding traffic. So if you will filter those all 300 prefixes from the routing table, automatically performance will increase. Getting my point? So for better performance, for better security, we are using what? Route filtering. Like let's suppose in company A, I have some critical network like 10.1.1.0/24. In this subnet, we have some critical servers. So I don't want to share this subnet with other companies because this is my critical data. But by default, EIGRP is going to advertise all prefix. So how you can filter this 10 subnet from 400 subnet with the help of route filtering. So it is for security as well. For better security also we are using what? Route filtering. Done. Why you are learning EIGRP routing protocol, right? You will not configure EIGRP routing protocol in the real time every time, right? Maybe hardly you will get chance to enable EIGRP on a new router. But by the way, guys, EIGRP will be pre-configured, already running in the network, in the topology. And you need to improve the configuration. You need to improve the network performance. So if you are a good network engineer, you know the filtering, you can improve the performance of network, right? You can improve the security. Getting my point? So benefit of route filtering. First one is improve security, like prevent the advertisement of sensitive and unnecessary route. You can tell to router, brother, this is the critical network. Please don't advertise to anyone. It will improve the security. Then optimized routing. Reduce the size of routing table. Will automatically improve performance. So reduce the size of routing table means improving performance. Then prevention of routing loops. Example can be, see the example. This is, guys, completely real-time example of a small company. Why I'm giving you example of a small company? So that you can understand the core technology, right? How we are using it. So imagine a company with two departments, HR and finance, each with their own network segment. Let's say 10.1.1.0 or 10.1.2.0. The company uses an internal network and connects to the internet via a router. They also connect to a partner company's network for a specific application, right? So there is link to another company for a specific application, right? Not to share complete routing information. In the real time, maybe you will have connectivity with another company for a specific prefixes, for a specific application, for a specific department. So you see, let's say for HR department we have this subnet 10.1.1.0/24. For finance department we have this subnet 10.1.2.0/24. And the partner network is 192.168.1.0/24. Partner network, another company. Now my objective is the finance department network should not be advertised to partner network for security reason. What I want? I don't want to advertise finance network, finance subnet. But if you will advertise, if you will enable EIGRP, by default EIGRP is going to advertise both network, right? So advertise finance department network should not be advertised to the partner network for security reason, while the HR network should be advertised. Solution: route filtering. To control which route? Advertised route. This time I am going to control advertised route. Or let's suppose in a company is receiving 100 number of route, and you need to allow only 10 prefixes or only one prefix. Let's suppose I have connectivity for a specific application, so I will allow maybe only one IP address or one complete subnet. So that time I need to control receiving traffic. Sometime you need to control advertised traffic, sometime you need to control receiving traffic, right? So guys, on the company router, what you can do, you can apply filter to only advertise HR network to the partner network. How to configure? First we need to create access control list here, access list. So define an access list to permit only HR network and deny finance network. How to create access list you already know. Access list number 10 permit this, access list number 10 deny this. So I have permit HR, I have deny finance. Clear? And after that, after creating the ACL, yesterday we had applied ACL on the interface of router, but today we are not going to apply ACL on the interface of router. Today we will apply the ACL under EIGRP protocol. So under router EIGRP 100, we can say distribute list and then number of access list 10, and in which direction? In odd direction, right? So now EIGRP will only advertise network which are permit in access list number 10, and access list number 10, in access list number 10 we have only permit this network, right? Got it? Clear, guys? So what is distribute list? Distribute list is a method to control advertised prefix or received prefix. What is ACL? ACL is a security feature which is used to allow or deny traffic. So a distribute list is a method used in routing protocol, not only in EIGRP, in other routing protocol also, like in RIP also. In routing protocol to control advertisement and acceptance of routes. It applies access control list, prefix list, and route map also to specify routes which are allowed or denied in the routing table. So right now I am talking about access list only, but guys, we have another security features as well to match traffic. Like right now I am using ACL to define the traffic, but I can use prefix list as well. We will see what is prefix list later. Now how many types of distribute list we have? So we have two types of distribute list. Either I can filter route in odd direction, or I can filter route in direction. So odd in, control routes being advertised odd from odd to neighbors. In means controls the route being accepted from the neighbors. Done. See the another example. A large company has three main departments: sales, engineering, and HR. Each department has its own network subnet. The company uses internal router to connect these departments together and has a connection to the internet. Additionally, there are branch offices that connect to the main office via WAN link. So let's suppose I have a scenario like this. Router 1 is connecting my all departments together: sales department, engineering department, and HR department. After that, this router is connected with internet, and guys, through internet I have another branch office somewhere, right? Router, then again switch, and then I have some servers, users, these things, right? And this router is also connected with internet. Maybe here we have different ISP2, and this is ISP1. Now both ISPs are connected together. So now can I configure this network in such a way so that these two offices can communicate? Yes. Simply I can create tunnel. We will see it later, right? How I can create one virtual private network over the public network. Between your edge router to edge router, right? You can create a virtual network. And on that virtual network, I can run again protocol, EIGRP protocol, to share routes. But again, let's say my requirement is I want to advertise only sales departments to remote branch office. So here I will create what? Access list. Then I will apply that access list in distribute list.
Yes, sir. Here ISP1 to ISP2, any new device is there in between or directly is
There are
connected to
lots
ISP?
of routers, brother. There are lots of routers. There are lots of paths available, by the way. ISPs are using different technology, right? Like MPLS. This is
Can
tier 1 ISP. Tier 1
can
ISP.
we? I have a question. Can we create access list from the R1 LAN, like some of the subnets or some of the IPs in the R1 LAN network to access some of the
If you will
to
apply
access some of the
access list,
resources?
brother, on the interface, that means we are
Yes.
denying the traffic, right? We are not
No, what
denying
I'm
the
saying
route.
is, can we apply the ACL on the virtual interface?
On the virtual, yes, we can. Yesterday we had applied ACL on the virtual interface 0/0.10.
Okay.
Yesterday we had applied ACL on the virtual interface, yes or no? We can apply ACL on virtual interface as well, right? But when I will apply ACL on interface, guys, whenever I want to deny the traffic, this time I am talking about the route filtering, how to filter network information, not user traffic, right? So in this scenario, what can be my requirement? Let's suppose R1, my internal router should only advertise sales network to the remote users, to the remote branch, or only engineering subnet, or only HR subnet. Or like on the remote, we have again 100 number of prefixes. But let's say router 1, on router 1, you want to receive only 10 number of prefixes. So what you can do? You can configure route filtering. Clear? So here you can see the objective can be what? For sales department, we have again same subnet 10.10.1.0. For engineering 10.10.2.0, 10.10.3.0, and for branch 192.168.1.0/24. My requirement can be company want to ensure that engineering network is not advertised to branch office for security reason, while sales and HR networks should be advertised. So requirement can be anything. If you know the concept, base concept, how to perform route filtering, how we are filtering the route, you according to your requirement you can filter the routes. Now can I start the configuration in my scenario? Is it clear? Is theory clear, guys, about route filtering?
Yes, sir.
Done. Good. So let me access these router. Router 1, router 2, router 3. First of all, let me configure these 3 routers. And I will use again last IP address from the subnet on router. So on router number 1, go to config T, then say interface F 0/0, no set, and IP address. IP address on F 0/0 10.1.3.254 255.255.255.0. Exit interface F 1/0, say no set, and IP address 10.1.4.254 255.255.255.0. Exit. Then interface F1/1, say no set, and IP address. I'm configuring router 1, right? So between router 1 and router 3, I will use what subnet? 13. 13.1.1.1 255.255.255.0. Exit. After that, router EIGRP. What is the AS number here? 10. EIGRP AS number 10. And network, I can say 0.0.0, or you can add all subnets here, right? Then say no auto summary also. Let me copy the command and let me paste it on router number 1, R1. Done. Now I'm going to save the configuration. To verify it, show IP EIGRP interfaces. So see, EIGRP is enabled on all interface or not? On fast Ethernet 0/0, yes. On fast Ethernet 1/0, yes. On fast Ethernet 1/1, yes. So IP interface brief exclude unassigned. the IP configuration. Done. Now guys, on router number 2, on router 2 F0/0, my IP address is going to be what? 10.1.1.254. F0/0 is connected with HR department. F1/0 is connected with sales department, so IP will be 10.1.2.1. On F1/0 IP address between router 2 and router 3, I will use 23 subnet. So let me say 23.1.1.2. Right, rest configuration is going to be same. Let me paste it on router number 2. Copy and paste. Done. So IP EIGRP interface. So IP EIGRP interface. Done. EIGRP is enabled on all interfaces. So IP interface brief exclude unassigned. Done guys. Now on router number 3. On router 3 F0/0 IP will be on F0/0 of R3 is connected with router number 2. So between router 2 and router 3, 23.1.1.3. On F1/0 is connected with router number 1. So IP address 13.1.1.3. And here on F1/0, 1/0 is not there. 1/1. On F1/1 between router 3 and router 6, leave these two interface for now. Done. Copy and let me paste it on R3. Now I am expecting EIGRP neighborship between router 2, router 3 as well as between router 1 and router 3. So IP EIGRP interfaces. See, EIGRP is enabled on both interface. And so IP interface brief exclude unassigned. Done. And so IP EIGRP neighbor. We have neighborship, correct? Q count is 0. So IP EIGRP topology. So see, in the topology table we have 10.1.1.0, we have 10.1.4.0, we have 10.1.2.0, 10.1.3.0. Done guys. So IP route EIGRP. Done. So see, router 3 have now these all internal subnet. So can I ping HR department? Ping 10.1.1.254. See, ping is working. Can I ping sales department? 2.254. Yes, ping is working. Can I ping admin department? Yes. Can I ping server department? Yes. Now let me configure these router, right? Routers in ABC corporate. So on router number 4, on F0/0, what will be the subnet? (20.1.1.254). On F1/0, 20.1.2.254. Then interface F1/1. No set and IP address. Between router 6 and router 4, let me use 46 network, 46.1.1.4, 255.255.255.0. Then router EIGRPS number 20 here. Let me copy the commands and let me paste it on router 4. Router 4, router 5, router 6. And let me paste the command on router number 4. Himnath, why are you joining now? So IP EIGRP interface. EIGRP is enabled, and so IP interface brief exclude unassigned. Done. then R5. So on router 5, F0/0 IP will be 20.1.3.254, and on F1/0 IP will be 4.254. On F1/0 IP will be between router 5 and router 6. I will use 56 network. So let me say 56.1.1.5. Between routers you can use any subnet, right? It depends on you. So I have configured all interfaces of R5 and then EIGRP as number 20 network 0000, no auto summary. Let me copy it and let me paste it on R5. Done. Then router 6. Guys, on router number 6, F0/0 IP address will be
53.
46 F0/0 between router 4 and router 6.
46.
46.1.1.6. And on F1/0 between router 6 and router 5, 56 network. So 56.1.1.6. Then leave these two interfaces for now. Then router EIGRP S number 20. Let me copy the command and let me paste it on R6. So IP EIGRP interface. So EIGRP is enabled on both LAN interfaces, and so IP interface brief exclude unassign. Done. And so IP EIGRP neighbor. Done, guys. Just a minute. Hello. Done. So here on router number 6, so IP route EIGRP. So see, router 6 also have all internal subnets. So now all departments in XYZ corporate as well as in ABC can communicate with each other. Yes or no?
Yes, sir.
No, they can't communicate.
Yeah. All departments can communicate, but guys, these two companies cannot communicate with each other. So what I can do, either I can
Yes.
extend EIGRPS number 10 network, or I can extend EIGRPS number 20 network, or I can use a different routing protocol between router 3 and router 6. So what option you want to use? Tell me. Do you want to use any other routing protocol here?
Different, yes, sir.
Okay, so let me use RIP version 2 here. Okay. I'm going to use RIP
Sir.
version 2, and between
Sir,
router,
excuse me. I'm so sorry. How about the we can distribute?
Yeah, here
do you
we are
think?
running RIP routing protocol. So what we need to do on router number 3, we need to redistribute EIGRP into RIP. Then RIP protocol will advertise it to router number 6. Again on router number 6, we need to advertise RIP into EIGRP. Correct? After that,
Yes, sir.
ABC corporate will get all networks of XYZ. Then we will redistribute EIGRP 20 into RIP here. Then router 6 will forward all ABC corporate network to router number 3, and again on router number 3 I will redistribute RIP into EIGRP 10. Got it?
What if there is no Ethernet cable between R3 and R6?
Not Ethernet cable. Which cable
I
you
mean,
have?
what about if there is no physical connection between R3 and R6?
Not physical connection. So if you want to
Yeah,
connect these two network together without cable,
without physical connection.
yeah, without physical connection, then what you can do, guys? Here you can add one access point, and then I can connect these two network wirelessly. Okay,
Okay.
we have multiple options, brother, here in wireless as well, right? But for now, just assume we have link. Or if there is distance, let's say there are more than between router 3 and router 6, distance is more than 100 kilometer. Then what option you have? You can take connectivity from service provider. You can take connectivity from service provider. Even you can place your dedicated cable. If distance is up to 100 meter, then you can connect both router with the help of Ethernet cable. If distance is more than 100 meter, then you can use optical fiber cable, right? But again, if distance is more than, let's say 100 kilometer or more than 100 kilometer, then you will take connectivity from service provider. There are multiple service provider in market like broadband, internet, MPLS. So we can use any transportation technology here. Now guys, see, between router 3 and router 6 I have two link. So either you can use both link or you can use a single link also, right? Let me use both link. See, on the upper link I am going to use 36 network, 36.1.1.0/24, and on the lower link I am going to use, let's say, 63 network, 63.1.1.0/24. Clear? So let me access again which router, router 3, and on router number 3, config T, interface F2/0, say no set, and IP address. IP address is 36.1.1.3, 255.255.255.0. But what is the issue over here? You can see I have enabled the IP address here. Do show IP EIGRP interface. See, EIGRP is enabled on 2/0 also. So guys, on edge router we cannot run network 0.0.0 command because it will enable EIGRP on their all interfaces. But on this interface I need to enable different routing protocol. Which routing protocol? RIP routing protocol. So I will remove EIGRP 0.0.0 command. Done. Then interface F1/1, no set, and IP address 63.1.1.3, 255.255.255.0. Exit. Now do so IP EIGRP interface. So see, EIGRP is enabled on both WAN port as well. Now let me take you to R6. Interface F2/0, say no set, and IP address 36.1.1.6, 255.255.255.0. Exit F1/1, no set, and IP address 63.1.1.6, 255.255.255.0. Will EIGRP neighborship come up between router 3 and 6? So IP EIGRP interface. See, EIGRP is enabled on these two WAN interface as well on router 6 as well as on router number 3. As well as on router number 3, you can see on both WAN interface EIGRP is enabled. Correct? Why we don't have neighborship, guys, between router 3 and router 6? See, on router number 3 or router number 6, so IP EIGRP neighbor.
Different AS.
Different AS, right? Both are sending hello message, but AS number will mismatch. So what I am going to do here, I am going to remove the EIGRP configuration, router EIGRP AS number 20 on router number 6, say no. and then say router EIGRP number 20 and network. Which network? 46.1.1.0 255.255.255.0. This command will enable EIGRP on F0/0. You can see again we have neighborship between router 6 and router 4. Then I am going to add one more network command, which is 56.1.1.0 255.255.255.0. Now I am expecting EIGRP neighborship between router 6 and 5. Clear? In the same way, here you can now verify. So IP EIGRP interface. Now you can see EIGRP is enabled only on LAN interfaces. Now let me take you to R3. On R3 also say no router EIGRP is number 10 here. What ES number here I have configured? 20, correct. On router number 3, no EIGRP is number 10. Then router EIGRP is number 10 and network. What network command? 23.1.1.0 and I can use wildcard mask as well 0.0.255. Then network 13.1.1.0 wildcard mask 0.0.255. Either you can use subnet mask or wildcard mask. So you can see now we have EIGRP neighborship between router 2 and router 3 as well as between router 1 and router 3. Do so IP EIGRP interface. Now EIGRP is enabled only on LAN interface. Now guys, let me configure RIP routing protocol between router 3 and router 6. So say router RIP, no auto summary and version 2. After that network. Which network? 36.1.1.0. This command will enable RIP on which interface? On F2/0 and network 63.1.1.0. This command will enable RIP on 1/1. So IP RIP, IP RIP database. So you can see RIP is enabled on F2/0 as well as on F1/1. Now let me take you to R6 and here say router RIP version 2 no auto summary and network 36.1.1.0 and network 63.1.1.0, right? So IP RIP database. So see RIP is enabled on both WAN interface, but so IP route RIP, we don't have any route. So guys, now let me verify the connectivity. Say, see, I am on router number 1, right? So on router number 1, let me do one thing. Let me configure IP address on these PCs. PC1, PC2, PC3, PC4, PC5, PC6, PC7, PC8. So PC1 IP address, let's say IP 10.1.1.1/24 and gateway IP address 10.1.1.254. Then PC2 IP 10.1.2.1/24 and 10.1.2.254. PC3 what happened to PC3? Okay. PC4 IP 10.1.4.1/24 and 10.1.4.254. PC5 IP 20.1.1.1/24 and 20.1.1.254. PC6 is also not working, 7 not working, 8. IP 20.1.4.1/24 and 20.1.4.254. Now let me take you to PC1. Can PC1 ping to PC2? Hello? Ping working?
Yes. Yes, sir.
Can I ping to server 4.1? Yes. Can I ping finance department in ABC network? Ping 20.1.1.1. No, ping is not working. Reason? My edge router don't have route. So router 3 will drop the traffic. Even router 2 will drop the traffic. Gateway don't have route. If you will check the routing table of router 2, so IP route EIGRP. See, we don't have route 420 network, right? So guys, I am going to perform now redistribution on router number 3 and on router number 6. So let me take you to router 3, and on router number 3, go to a router RIP and say redistribute EIGRP ES number 10. So you are redistributing which protocol in RIP? I am under RIP routing protocol, and under RIP routing protocol I am redistributing what? EIGRP ES number 10. And then guys, metric in RIP is hop count. So you can define the hop count or you can leave it on default. Even I can hit enter like this. But if you want to advertise network from XYZ corporate to AB corporate with, let's say, hop count 5, right? So you can add the metric. Now let me take you to router number 6. And guys, on router number 3, if you will check RIP database, so IP RIP database now. So you can see RIP routing protocol have only these two network information here. What happened? So IP route RIP. Router RIP version 2, and where is the redistribution command? Say no to this and redistribute EIGRP ES number 10, and let me add the metric. I think I can note redistribute without defining metric. Now let me check. So IP RIP database. Now you can see RIP routing protocol have installed all EIGRP routes in their database, and now RIP is going to advertise it with router number 6 to their neighbor. So now on router number 6, so IP route RIP. So you can see router 6 is learning these all networks. 10.1.1.0, 10.1.2.0, and see the unwanted prefixes 13, 23. These are what? Unwanted prefix, right?
So without redistribute, it's not gonna.
Yeah, without redistribute, it will not. Yes, two different routing protocol cannot communicate.
Okay.
Done. Now guys, on the router number 6, see we have two types of routing table. So IP route RIP, this is RIP routing table, and so IP route EIGRP, we have EIGRP routing table. So in EIGRP routing table we have internal networks. So what I want, see we have EIGRP neighborship between router 6 and router 4, as well as between router 6 and router 5. So if I will insert RIP route into EIGRP, then router 6 will advertise it to their neighbor, yes or no? So now I need to redistribute RIP into EIGRP here. So let me take you to router number 6, and on router 6 I'm going to say router EIGRP S number 20 and redistribute which routing protocol? RIP, and then metric. In EIGRP, what is metric? K values. So define the K values. What will be the bandwidth? Let's say bandwidth is 10,000 kbps. Then delay.
1.
No, delay value, brother. See, if you will advertise any route in EIGRP domain, you have to tell what K values they will use. Means what will be the bandwidth. Because remember the metric calculation in EIGRP, if we have two router R1 and R2, whenever R1 will advertise any network information, it will advertise bandwidth and delay. Correct? And with the help of that bandwidth and delay, router 2 is going to calculate metric. In the same way here I am injecting some rip route into EIGRP, so I have to define bandwidth and delay. So delay is, let's say 10, then load.
So delay is only for that link, or
No, delay for all the prefixes coming from RIP to EIGRP. Whatever prefixes you will redistribute from RIP to EIGRP, for those prefixes it will use this bandwidth, this delay to calculate metric.
so for an example here, two IGRP routers is running. So we are giving the 200 milliseconds, right, sir?
Yes.
Okay.
Then hit enter. Now you can see show IP route EIGRP. Still we don't have route show IP EIGRP topology. In the topology table, guys, 10.1.2.0, 10.1.4.0, 10.1.3.0. So it have installed these all network in their topology table. So IP route EIGRP. But it have not installed in their routing table. Go to router 4 and show IP route EIGRP. Now you can see on router number 4. By the way, router 6 will also install all prefixes in their routing table, then it will advertise it to their neighbor, to router number 4. So now see on router number 4, we have two types of EIGRP route. Few are, guys, external route, EX means external. And for external routes, AD value is 170. And few are internal route, these are internal. For internal, AD value is 90. And see, all routers have calculated the metric on the basis of bandwidth and delay, which I have defined while redistribution. Now can PC1 ping to finance department, means PC5. See, earlier I was not able to ping. This time also I am not able to ping. Why? Why, guys? Because see, these routers in ABC corporate have route of XYZ, but XYZ company don't have route for ABC. Yes or no? So now we need to inject, we need to redistribute EIGRP route into RIP routing protocol here and
RIP to EIGRP.
EIGRP. Very good. So let me take you to again router number 6. And on router number 6, say router EIGRP is number 20 and redistribute
RIP
RIP.
metric.
Sorry, not in EIGRP. You need to redistribute EIGRP into RIP, right? So router
Yes.
RIP and redistribute EIGRP. ES number 20 and then metric, let's say 5. So this metric is also very important. Let's say if I will define metric here, what, guys? 14. If I will define metric 14, will it work?
Sir, excuse me, you have to put here the hop count.
Yes, hop count. This is hop count.
But you put there metric.
Metric
Yes.
in the distance vector routing protocol is hop count, na? Metric in RIP routing protocol is hop count. Yes or no, guys?
Because I'm so sorry, because you know what? Whenever you want to inject the ERGRP inside of the RIP, because based on the RIP routing protocol, we have to put here, I think, hop count. I mean.
So this is hop count, bro.
Oh. Okay, thank you.
Right? So guys, let's suppose I want to add some route in RIP routing protocol. I have to define what? Hop count. If I am injecting some route in EIGRP, then I have to define what? K values. correct? Because EIGRP calculate metric on the basis of k values and RIP calculate metric on the basis of hop count. In the same way, if we have OSPF and I am adding some route in OSPF domain, then I will define that value which OSPF uses to calculate metric, correct? And same concept for other routing protocol as well, for BGP or for ISIS. Now, so IP RIP database. So you can see now RIP have installed these 20 networks in their database, and router 6 will advertise it to router number 3. So on router number 3, so IP route RIP. So you can see I have learned all 20 networks. Now I need to inject these 20 network into EIGRP, correct? Because so IP EIGRP topology. Till now, see, we don't have any 20 network here. So now let me redistribute RIP into EIGRP 20, router EIGRPS number, sorry, 10, and redistribute RIP. And then metric. What is the metric in for EIGRP? K values. So define the bandwidth value, define the delay, define the reliability, define the load. But again, your EIGRP protocol will use only K1, bandwidth and delay by default, right? It will not use MTU, it will not use reliability, it will not use load. Enter. Now, so IP EIGRP topology. You can see it have installed 20 network in their topology table. Now router 3 is going to advertise it to their neighbor, means to router number 2 and router number 1. So on router number 2, so IP route EIGRP. You can see we have all 20 networks, external networks, right? In the same way, guys, on router number 1 also you can verify the routing table. So IP route EIGRP. We have all 20 networks, right? And these are external prefix, so AD value is 170. Now see on router number 3. On router number 3. So IP EIGRP topology. Guys, what subnet here I am using between router 6 and router 4? 46. What subnet I am using between router 5 and router 6? 56. So router 2 is going to redistribute these prefixes as well in EIGRP, right? So that's why on router number 36C we have 56 network also. We have 63 network. Okay, 63 is directly connected. And we have 46 network also. But what I want, router 3 should only advertise this network. These are wanted prefix. These are unwanted prefix. Like the network which is running on this link, these are unwanted because these PCs are never going to ping 46 network or 56 network. My requirement is end-to-end connectivity, right? So I need to now filter the route. So on router number 3, I am going to create one access list. Access list number 10. Permit which network? 20.1.0.0 wildcard mask 0.0.255. See, all the department subnets are matching in this subnet or not? Yes. All the departments subnets are matching in this network. Yes or no, guys? Access list number 10, permit. Where's the, okay, wildcard mask is incorrect. I've created the ACL. Do so. Access list. See the access list number 10, which is permitting only 20 network. Now what I want, that router 3 should only receive prefixes which are allowed in this ACL. Means on router number 3, EIGRP should only receive those prefixes which are defined under ACL number 10. So what I can do, I can configure distribute list. So say router EIGRP AS number 10, and before applying it, see the routing table of router 1, right? Routing table of router 1 have lots of unwanted prefixes, right guys? Right? So let me say distribute list access list number 10, and in which direction? In direction that whenever you will receive update message of EIGRP, check access control list and check what prefixes are allowed there. Enter. Now go to again router number 1 and clear the routing table, clear IP route star, and show IP route EIGRP. Now you can see I am not receiving any unwanted prefixes from ABC corporate, yes or no? I am only receiving these 420 subnets. Yes or no guys? Clear?
Yep.
Here we have again some unwanted prefix, like you can see 23 network, 36 network, 46 network. These are what unwanted. On router number 1, I only want to receive 20 network and 10 network. So I can say access list number 10 permit 10.1.0.0.0.0.0.255.255, and then access list number 10 permit 20.1.0.0.0.255.255. Router EIGRP is number 10 distribute list number 10 direction in, and clear IP route star. So IP route EIGRP. Now see the routing table. What happened? So access list we are allowing 10 and 20. That's fine. So IP route EIGRP. So IP EIGRP topology 10.4.0 is there, 10.3 why we don't have 10 networks here. So IP, so access list 10.1.0.0 wildcard mask, that is fine. So it should accept 10 networks as well here. Router 1 I have applied in indirection, means while receiving the update message it will check ACL. So IP protocol, and in the protocol you can check the filtering. Now you can see outgoing update filter not set, but incoming update filter set for all interface is 10, and in the access list 10 we have permit 2 subnet, right? 10 and 20. So this router should receive 20 network also, 10 network also. So IP route EIGRP. Let me do one thing. Let me remove the ACL router EIGRP as number 10, and let me reboot this command first and do so IP route EIGRP. Just wait for some time. Now I am receiving all networks.
Can we redistribute for static route too?
IP access list standard 10 permit 10.1.0.0.0.255.255 no access list number 10 IP access list standard number 10 permit 10.1.0.0 0.0.255.255 and permit
Hello, sir.
20.1.0.0. Hmm?
Sir, I have a doubt, sir.
Yeah, go ahead.
Sir, how this is 10.1.0.0?
So actually, see the wildcard mask. Wildcard mask is 0.0.255.255 means I am saying only match 16 bits. If value in the first octet is 10 and value in the second octet is 1, then permit that network. It
Then,
will.
sir, you mentioned slash 24
Where is slash 24?
in picture.
Bro, slash 24. See, with slash 24, I am matching this subnet, right? This subnet, this
Yes.
subnet, this subnet. But with the help of slash 16, we can match all network in one subnet. In this subnet, see, all these subnets are coming, right? Matching. Yes or no? So instead of
Yes, sir.
running 4 permit command, I am running single permit command.
Okay, sir.
Now distribute list number 10 and direction in on fast ethernet, let's say 1/1. On the interface also you can apply distribute list. So IP route EAGRP. Wait for some time. EAGRP neighbors will resynchronize. Yes. Why it is filtering 10 network? It should not filter 10 network, by the way, here. Go to router number 1 and so access list. Actually router 3 is not advertising. See, on router number 3 we are only allowing this network, right? So guys, router 3 will remove 10.1.1.0 network. So IP route EAGRP. See, on router number 3. So IP route EAGRP. Router 3 is not learning now 10.1.1.0 and 10.1.2.0, these two network. So actually here we need to modify the ACL on router number 3. On router number 1 everything is working fine. Here say access list number 10 and permit 10.1.0.0 wildcard mask 0.0.255.255. That's it. Now go to router number 1 and on router number 1 so IP protocol filtering is not set. Let me set the filtering. Do so access list. So okay, access list is fine. Router EAGRP yes number 10 and distribute list number 10 in indirection. Done. So IP route EAGRP. Just wait for some time. After some time EAGRP neighbors will resynchronize. Done. And now you can check the routing table. So IP route EAGRP. See guys, now routing table looks very fair. Yes or no?
Yes, sir.
In the same way on router number 2, so IP route EAGRP. See the routing table. What we can do? We can say access list number 10 permit 10.1.0.0 255.255.0.0 and permit access list number 10 permit 20.1.0.0 0.0.255.255. Router EAGRP is number 10 distribute list number 10 direction in. Oh, I have applied it on router number 4.
I think
No problem.
I think I think that should be AS number 20, eh?
Yeah, AS number should be 20 here. No router EIGRP AS number 10. Done. Actually, I was applying it on router number 2. Let me apply again. Access list number 10 permit 10.1.0.0 This is subnet mask, but here I need to define wildcard mask. And guys, 20. Then router EIGRP S number 10 distribute list number 10 direction in. So IP route EIGRP. Done. So routing table should have only necessary network information, right? Now on router number 1, you can see we have filtered the unwanted prefixes. On router number 2 also I have filtered all unwanted prefixes. On router number 4, access list is already running, so access list is already there. Router EIGRPS number 20 distribute list number 10 direction in, and
Sir,
even I
I have
can
a
apply it
question.
on interface. Yes.
Sir, excuse me. Just question. If in case you put out, what would happen? Instead in,
So while
if you put out.
advertising up EIGRP update message, it will check ACL. In this scenario, when router will receive the update message, in that scenario it will check ACL number 10. If I will set the direction out, then while advertising the update message, it will check ACL. Now so IP route
Thank you.
EIGRP. Here why we don't have 10 networks. So IP so access list. Access list is incorrect. No access list number 10. Access list number 10 permit 10.1.1.10.0.0 0.0.255.255 and 20. So IP route EIGRP. Wait for some time. Clear IP route star. So IP route EIGRP. Done. In the same way, I can filter unwanted prefix on router number 5 also. Access list number 10 permit 10.1.0.0 0.0.255.255 and 20, and then say router EIGRPS number 20 and distribute list number 10 direction in. So IP route EIGRP. Wait for some time till EIGRP neighborship will resynchronize. Yes, now you can check. Done, guys. And you can verify the connectivity. Let me take you to PC1 and now ping 20.1.1.1. See, ping is working. Ping is working. Ping 20.1.2.1. IP is not configured on PC number 6, I think. Yeah. PC 6. Okay, PC 6 is not working. I have to replace the device. Then let me ping PC 7 or PC 8, which is 4.1. See, ping is working. I can ping PC 4 also. Ping 10.1.4.1. PC4 ping is working, correct? Now let's suppose Right now see the routing table of R1. So IP route. Guys, so IP route, this is the entire routing table, and so IP route EIGRP. We have all other network routes. Yes or no? ABC corporate networks. As well as we have internal network. Internal networks have AD value 90 and external network has AD value 170. On router number 2 also you can see. So IP route EIGRP. Done. Then router 4. So IP route EIGRP. Router 4 have also all other network information, other company network information, means XYZ corporate as well as their internal network. Internal network have AD value 90 and external network has AD value 170. Then router 5, so IP route EIGRP. Done. Now my requirement is XYZ company should only advertise sales subnet to ABC corporate. What I am saying, XYZ company only need to advertise sales subnet, means 10.1.2.0/24 to ABC, means EIGRP 20. See, I have two options. I can apply filtering on router number 3 or I can apply filtering on router number 6. If I will apply filtering on router number 3, then direction is going to be out. If I will apply filtering on router number 5, then direction should be in. Right? See, we have merged these two company, XYZ and ABC. But you know, we have merged, but we need a specific communication between two buildings, like sales department and sales department should be able to communicate. Then server should be available from these all departments. So these are your requirement. Here I am writing the scenario. Both sales department or R3 should only advertise 10.1.2.0/24 to ABC Corp. R6, sorry. R3 should only advertise sales network to R6. That means all users in this department can ping sales user. Correct, guys? But let's say only sales and sales want to communicate, means R3 should only advertise which network? This network, and R6 should only advertise this network. So let me correct it. R3 should only advertise this network to ABC and R6 should only advertise 20.1.2.0/24, sorry, 3.0/24 sales. This is my
3
task.
dot.
Yeah,
Sir, 3 dot.
20.1.3. Okay, good. Now guys, later on, let's say my scenario is changed. Now my requirement is server should be accessible from everywhere. Now tell me how you will configure the route filtering. How you will configure the scenario? That means router 3 now should advertise two network. One is 20.1.2.0/24 as well as, sorry, not 20, 10.1.2.0/24 as well as 10.1.4.0/24, and router 6 should only advertise
20.1.3.
then how these user finance people can communicate with server? Not possible, right? So R6 have to advertise entire network, correct? Because guys, what I am saying, server should be accessible from everywhere. So finance people should also able to access the server. That means router 1 need a route for,
But if we do R6 only accept 10.1.2.0 or 10.1.4.0,
this was my first requirement, but now my requirement has changed. So this was earlier configuration. Let's suppose you have joined the company, right? And in the company, guys, this is the scenario. And now manager told you to configure the scenario like this. Server should be accessible from everywhere. So from router number 3 you need to advertise this subnet, and from router number 6 you need to advertise these all subnet. Yes or no? Is it clear to all? So router 6 is advertising all subnet. Now let me take you to router number 3, and on router number 3 I'm going to create one ACL access list number
30.
30, let's say. Then permit 10.1.4.0 wildcard mask 0.0.0.255 and a router EIGRP S number 10, distribute list distribute list number 30 and direction out. Now if I will define interface F2/0, then what will happen? From F2/0 it will advertise only this network, but from F1/0 it will advertise all network. So that's why here I will not define the interface, so it will apply it on all their interfaces. Done. Now go to any router in ABC corporate. So in ABC corporate we have router 4. So let me take you to router number 4, and on router number 4, guys, see, this was the earlier routing table. Now show IP route EIGRP. Why? Why? What happened? How router 3 is advertising all networks? So IP, so run section EIGRP, router EIGRP 10, distribute list 10, direction in. Okay, this is in direction means for upcoming. So for incoming traffic, and this is in odd direction means for outgoing traffic, and in access this 30 we are allowing only one subnet. Now when you troubleshoot it, why it's not working? Router 3 should not advertise these all prefixes now. So actually, you know what is happening? EIGRP router 3 have two EIGRP neighbor, right? EIGRP have two neighbors. So while advertising prefixes to their neighbor, EIGRP will check access control list. But guys, on router number 3, actually we are redistributing EIGRP into rerouting protocol. So filtering will work while advertising prefixes to their other neighbor. Whenever router 3 will advertise route to R2, whenever router 3 will advertise network to R2, it will check filtering. So see on router number 2, show IP route. Now here it is only advertising what? It is only advertising 10.1.4.0/24. So this is why filtering is very important. Whenever you will configure the filtering, you will plan it first, that other departments or networks should not impact, right? So here I was configuring filtering to advertise only one subnet to other companies network, right? Like to ABC corporate. But here I have applied a filtering for our internal subnet. So what we can do? We can form one EIGRP neighborship on one link, and after that we can configure ACL like this on a particular interface. So see why I'm using two link here. This is the reason. Now I am going to configure upper link in EIGRP. On order number 3, I'm going to configure upper link in EIGRP S number 10. So say router EIGRP 10 and network 36.1.1.0.255.255.255.0, and then router rip do so run section rip. I'm going to remove this network command 36. Now on router number 6, also I need to do same thing, router EIGRP AS number 10 and network 36.1.1.0.255.255.255.0 and router rip do so run section rip. Let me remove one entry, one network command, that is this 136. Now on router number 2, two process of EAGRP is running on router number 6. On router number 6, so IP protocol. See how many protocols are running. First routing protocol is EAGRPS number 20. Then guys, RIP. Then EAGRPS number 10. Okay. So that's why you should not use here what RIP routing protocol. Here you should extend EAGRPS number 10, or you can extend EAGRPS number 20. If you will extend EAGRP 10, right, till here, till router number 6, then you only need to perform redistribution on router number 6. But if you are using any other routing protocol here, then guys, we are redistributing traffic on router number 3 also, as well as on router number 6 also. So again, if you are redistributing traffic at lots of router, it will decrease the performance, right? So simply what I can do, I can say no router EAGRP on no router RIP on router number 3, no router RIP. I have removed the RIP configuration. On router number 6 also, say no router RIP. I have removed the RIP configuration, right? And here do so IP EAGRP neighbor. Now you can see router 6 have 3 neighbors, 2 for AS number 20 and 1 for AS number 10. For AS number 10, who is the neighbor? Router number 3. For AS number 20, 2 neighbors. And now on router number 6, I can advertise AS number 10 into 20 and 20 into 10. So do so run section EAGRP. I am going to remove some command. Router EAGRP AS number 20, and from the 20 I am going to remove this command. Say no to this, and on router number 3, router EAGRPS number 10, and do so run section EAGRP. Now I don't need to perform redistribution on router number 3. Now again on router number 3, so IP route EAGRP. So you can see we have only internal subnets because I have removed the redistribution. And on router number 6 also, so IP route EAGRP, we have only internal subnets. Correct, guys? Now what I can do, I can redistribute EAGRP 10 into 20 and 20 into 10. So say router EAGRP number 10, redistribute EAGRP 20, and say metric, bandwidth, delay, reliability, load, MTU. Then router EAGRP 20 and redistribute EAGRPS number 10, say metric, so IP route EAGRP. Now go to router number 4. So in ABC, we are advertising only which network? Server networks, right? And as I told you, sales department should also communicate with each other. So what I can do on router number 3, I can modify the ACL. So access list. So guys, in access list 30, I am going to add 10.1.2.0 router, sorry, access list number 30 permit 10.1.2.0 wildcard mask 0.0.255.255. Done. So IP route EIGRP, just wait for some time, soon it will receive 10.1.2.0 also. Done. So now sales department, both sales departments can communicate with each other, as well as all user in ABC corporate can access server department in XYZ network. So you can see in the ABC corporate, in other company network, guys, we have only two subnet from ABC, from XYZ. We have only two subnet from XYZ. On router number 5, so IP route EIGRP on router number 5 also. But on router number 1, so IP route EIGRP. Router 1 have only this network information. Reason? Because of ACL on router number 3. So on router number 3, we should not configure ACL like this. See, so run section router. What is happening? We have distribute list number 10 direction in. So while receiving traffic, it will use this ACL, and while advertising traffic, it will use this ACL, ACL number 30. And guys, in ACL number 30, so access list, we are only allowing these two network. So this ACL should be applied on F2/0, which is connected with router number 6, not for the all neighbors, right? If you will apply it for all neighbors, then there will be issue with internal connectivity. So let me say router EIGRP is number 10 and no distribute list number 30 direction out and no direction 10 direction in. Now distribute list number 30 direction out on which interface? On fast Ethernet 2/0. Now you can see the routing table of R1. Just wait for some time. Done, guys. All internal subnets are there, all external subnets are there. On router number 2 also, so IP route EIGRP. All internal subnets are there, as well as all external subnets are there. In the ABC corporate, means on router number 4, so IP route EIGRP. All internal subnets are there, as well as two external subnets are there. On router number 5 also, so IP route EIGRP. All internal subnets are there and two external subnets are there. Done. Now guys, if you will open any external network in detail, so IP route and let's say 10.1.4.0 255.255.255.0. So first of all, see the network type is external, and we can filter route on the basis of network type as well, on the basis of route type as
Hello,
well.
sir.
Hello?
Hello, sir.
Yeah.
For router number 5, which network are external?
For router number
It's
for router number 5, this network 10.1.2.0 and 10.1.4.0, this one and this one. For router number 5. Why, bro?
why,
Is
sir?
it not clear to you? Because on router number 5 we are running AS number 20 and these networks are in AS number 10.
Yes, sir.
So that's why on router number 5 these networks are external network.
Okay, sir.
Sir, I have a question.
All redistributed network will be considered as external network. Yes, Bhaijan.
Sir, excuse me. On R3, if we disconnect the F2/0, you
Okay.
think we can distribute all of the, let's say, sales department and server department to the this side, I mean ABC Corp through F1/1?
Okay. No, but right now we don't have neighborship on this link. I am using only one link, upper link.
Okay, thank you.
Now, if I have two link here, I can achieve load balancing, or I can perform path manipulation. I can advertise some network from this interface, some network from this interface, right? Like I can allow, let's say, this network and this network from this interface, and this interface and this interface from this interface.
Okay, thank you.
Right, guys? So if you will open a network, external network in details is network type. And if you will open internal network like 20.1.4.0, 1.0. So see, type is internal. So guys, on the basis of network type also we can perform filtering. On the basis of metric also we can perform filtering. I can configure this router in such a way so that it will match metric. If metric will match, then only it will perform filtering. Right now we are filtering traffic on the basis of network, subnet, right? But we have many more options. Like while redistribution, I can even add some tag number, right? Let's suppose now your scenario is different. Scenario is finance and management. These two branch offices should be able to access the server, but sales and voice should not be able to access the server. So from the router number 3, you are going to advertise server. That means router 4 and router 5 both will have that network information. Correct, guys? Correct? But what I can do, while redistributing it into EIGRP, I can add one tag number, right? I can add some tag number, and on the basis of that tag value I can perform filtering. Let's say when I am advertising ABC corporate, all network of ABC corporate into XYZ. So I will add tag number with these two prefix. Tag number is 10. So now on router number 3, I can perform filtering for those prefixes who have tag number what? 10. So router 3 will filter only these two prefixes, these two subnets. In the same way, let's suppose we have some prefixes coming from other company, right? Let's say another company is created over here, and I am getting all network from this company into this company with metric, let's say 1 2 3 4 5, and someone have told you to filter these prefixes coming from this company. So what you can do, you don't know what prefixes are coming, right? Like 10 dot or 20 dot or 30 dot 40 dot. You know the metric only, that I need to filter prefixes who have this metric. So yes, you can filter the prefixes on the basis of metric. So now guys, in next video we will next class we will see rest types of filtering. Today we have seen the basic idea about the route filtering, why we are using it, and in the next class we'll see how many options we have to filter network information, and then we will start what next protocol, that is OSPF, right? And EIGRP and rerouting protocol is okay. These are distance vector routing protocol. Most of the companies are using, but not most, means few companies are using EIGRP, but most of the companies are using OSPF routing
OSP.
protocol, right? So make sure you are going to learn OSPF very carefully. Guys, we will have maybe 6 to 8 sessions for OSPF, so that we can discuss each and every point. Done. But while explaining OSPF, I will use concepts of distance vector and advanced distance vector routing protocol, like concept of EIGRP and RIP. Like I will compare many times EIGRP with OSPF, and then I will teach you. I will make you understand the concept of OSPF. Like I can say, see how OSPF will form neighborship between two router. So I can take reference of EIGRP neighborship here between router 1 and router 2. So that's why EIGRP is important, or RIP, even RIP is important, because while explaining EIGRP I had used RIP routing protocol as a reference. Got it? That's all for today now. Now if anyone have question, please ask. Otherwise tomorrow again we will have session for route filtering only. Are you guys doing lab or not by yourself?
Yes, I do.
Yes, sir, we do actually.
Yes, I
Yes.
do.
So because it is very important, make sure after the class or before the next class, you will configure these all filtering, right? Whatever filtering we had discussed in ESERP, because see, we are going to learn filtering again in OSPF, and filtering concept is similar, exactly same. In EIGRP, we can perform filtering on any router, but in OSPF, we can perform filtering on a specific router. That is the only difference, but concept is going to be same. There also, to filter route, I will use ACL. And guys, in next class tomorrow, we will see another features to filter prefixes, like prefix list, and route map.
Sorry, excuse me. How about metric?
What is
The filter in the matrix?
matrix means?
I mean, if you
Yes,
want, for
if you want to
example,
filter route on the basis of matrix, then you have to use route map. With the help of route map, I can match matrix. See, in ACL, we cannot match matrix, right? With the help of ACL, guys, we can match what? Subnet, network ID, correct? With the help of prefix list, we can match what? Prefix length. Like I can tell to router, please filter the network who have length of 24, or prefix who have length of /26. And with the help of route map, I can use like tag value, metric value. I can tell to route map, please match metric. Like in ACL, what we are seeing, match this network, match that network. In prefix list, I can say match that network with this prefix list, this prefix list. In route map, I can say what? Match metric, match this tag number, like that. Okay. So now let me send the recording to you.